All right, let's get back to it. Go. All right, we just learned the product and quotient rule. Let's try out these examples. Find the derivative. We got some good ones. And you can see, product rule here. Looks like a quotient rule. And then, a little something. Oh, we got just like a f of x, like an unknown function, a general function. And then this will be an awesome finale to this set of examples. Okay, let's switch over and take a look. Find the derivative. We'll start with n of x equals negative 9x squared plus 2x, and that's being multiplied by e to the x. So we've got a product here, and I'm going to go ahead and underline both parts. So we're looking for n prime of x. Okay. This derivative, now you might think, should we distribute the minus sign first? You don't need to do that. You can think of this minus sign as being a constant multiple. So it just carries down. Then you can take the derivative of each part. So there we've got 18x plus 2 as our derivative. That's going to get multiplied by the original second function, e to the x. So derivative and a copy plus, and now we copy here, but it's negative 9x squared plus 2x. That gets multiplied by our derivative, derivative of e to the x. And now let's clean it up. If this was a quiz or a test, I'd be perfectly happy with this. No need to simplify anything. I can see the product rule happening perfectly. Love it. But, if you just want to have a little practice, not really a whole lot to do here, right? It's almost really just that. It's just that plus a negative. I mean, what else are you going to do? I'd even say, don't even bother with this. Like, could you factor, yeah, you could. Well, let's check it out. I didn't even realize that. Okay, so the negative can factor, and then we'd have 9x squared plus 18x plus 2x is plus 20x plus 2. All right. Yeah, that does look a little bit better. I kind of like this one as a simplified. Let's get rid of this box. I do this sort of thing, and I could do this video over again, but I'm not going to, because that's real. Okay, didn't realize it could have been simplified further before just now. All right, there we got it. Again, quiz or a test, and if this is all I'm asking, boom, stop right there. Let's take a look at the next one. We were calling it y equals 2e to the x over square root x. I think like, okay, quotient rule, but we've got this square root. We need to rewrite that before we do anything. That's x to the 1/2. Okay, now we're ready. Let's call this y prime. Quotient rule says low times the derivative of the high. Well, this derivative would still be 2e to the x. Low d high minus the high. And now the derivative of the low, this is interesting. The 1/2's gonna move down. And we subtract 1 from the power. Well, 1/2 minus 1 is negative 1/2. Low d high minus high d low, and it's all over the low squared. If this was a quiz or a test, you can stop right there. You got the derivative. There is definitely some simplifying to do if you wanted to, but if all I'm asking for is the derivative, that's not what I'm after. I'm just trying to understand, do you know the quotient rule in this case? But you know what, just for the practice, let's go ahead and start simplifying. There are some simple things to simplify and some not so simple. Let's see here. Let's write this as 2x to the half e to the x. Kind of like to put that 2 in front. Minus, here the 2's cancel. I'm going to call this x to the negative 1/2 e to the x over. And now when we square here, we just get x again. Now you might think that this is completely simplified. It's actually not. With that negative exponent, this is actually a fraction, right? X to the negative 1/2 is the same as 1 over x to the 1/2. We cannot have in a simplified answer a fraction within a larger fraction. That's not completely simplified. So here's what we're going to do. We're going to multiply, if you thought of it this way with that denominator, we're going to multiply the top and the bottom by that denominator. Going to cancel it out. And it's actually going to clean up some other things just kind of conveniently. So if we multiply the top and the bottom by x to the 1/2, let's think it's going to distribute here, and x to the 1/2 times x to the 1/2 just becomes x. When it multiplies here, it's going to cancel, and that'll be gone completely. Or, if you want to think of it as an exponent this way, if you multiply the exponents add together, that'd be x to the 0, which is just 1. Either way you do it, it's minus e to the x, and in the denominator, now here we do want to add the exponents, x to the 1/2 times x to the 1st, x to the 3/2. And there's a nice simplified version. I like that. It's kind of nifty. You know what? As much as I like this quotient rule, I'm thinking about that negative exponent. You know what? We could have done this a different way from the beginning. Let's take a look. 2e to the x over x to the 1/2. Wouldn't that be the same as 2x to the negative 1/2 e to the x? If we put that in the numerator with the negative exponent. And if we wanted to think of it this way, we could then use the product rule. Oh man, let's check it out before we move on. Let's do this derivative again, but with product rule. I wrote y prime there. This is actually just y, my mistake. Y prime. With product rule, this derivative, let's see, the negative 1/2 multiplies, cancels with the 2, so it's negative x to the negative 3/2 times e to the x plus 2x to the negative 1/2, and then that derivative is just e to the x again. And so there's another way, and that's quite a bit simpler, right? I mean, if you like product rule versus our quotient rule, that sure made things a lot easier. Keep that in mind, whenever you see a function, there might be more than one way to go about getting the derivative. And all of these rules are consistent so long as, you rewrite something, like this, these two derivatives here, these are equivalent. It doesn't appear so at first, but let's see, I think this actually would become that second part. And then this piece would become this part, and they both have, if you found a common denominator, that would all work out. I'm going to leave that to you guys. If you want to explore it, you could, think of each piece this way, right? Put those back in the bottom and say, okay, there's my negative e to the x over that x to the 3/2. Here I can multiply top and bottom by x. Okay, you get the idea. Let's go on. I'm just gonna flip my page over, look at that. Let's go on to part C. What was part C? T of x equals 8x to the negative 3 f of x. This is interesting. We've got a product rule. T prime of x. This derivative, negative 24, x to the negative 4. And for now, I'm just going to copy f of x. That copies over, okay. Plus 8x to the negative 3 times, and you think, well, what are we going to do with f of x? I mean, I don't know what the function is. What's the derivative? Well, that's okay. We're just going to write f prime of x right there, the derivative of f. And there you have it. Negative 24 x to the negative 4 f of x plus 8x to the negative 3 f prime of x. Not much simplifying to do for that one. There you go. We got one more. It's our big finale. B of x equals 3x e to the x plus 6 over x to the 4th minus 1. Okay, so we're going to approach this with a quotient rule. But when we do, we want to be really, really careful. It turns out that there is a product rule involved in this as well. If you take a look, the numerator has 3x e to the x. In performing the quotient rule, we're going to need to take the derivative of the numerator. And the whole thing, the derivative of the 6 will be 0, but the derivative of this part will need to apply the product rule. At this point, you know, this can be a bit shocking for students. Like, what? There's a product rule within a quotient rule? Yes. Actually, this sort of thing has been happening with all of our rules so far, right? Even look back here, we've got this product rule, but within the product rule, you know, we did a power rule. You know, all right. So we've been doing this sort of thing. Rules, you know, are kind of like building up and can always occur in multiple layers as we learn them, and they interact with one another. But we really don't like experience it fully, probably until this moment where we've got something like a product rule within a quotient rule. So let's begin here. We'll just kind of note, like, the big idea is quotient rule. But within that, there's a product. Let's see how it plays out. B prime of x. So starting with the quotient rule, low, I'm going to put this a little bit lower. I'm not sure how far over it's going to extend. B prime of x, low, all right, times the derivative of the high. Now, what you might want to do, there's a couple ways, because that derivative of the high uses another rule, you might kind of do that out on the side. In fact, what some students will do, and it's pretty clever and it helps you to stay organized, you know, you can write like the high equals 3x e to the x plus 6, and then you can do the d high, you know, kind of right here. And then, you know, you can write the low and the d low, you know, maybe something like that. And then just kind of put the pieces into the puzzle where they need to go. I'm definitely not going to have space to write all this now. Okay, let's see. Let's do the d high. So here, right, the derivative of the 6 would be 0, so we can forget about that. This product rule, well, that would be 3 e to the x plus 3x e to the x. Okay, very nice. Low and d low, that would be 4x cubed. Okay. Let me move maybe over here. That'll work. So doing this, we've got low times d high, 3 e to the x plus 3x e to the x. Low d high minus, oh man, okay. the high times the d low. Not giving myself enough room. All right, we're just gonna have to come down here, I guess. B prime, low, D high, minus the high times D low. Let me look again, low D high minus high D low, perfect. And it's all over the original low squared. Love it. Or a test or a quiz, if we're asking for a derivative, stop right there. But just for the practice, why not? Let's see what we can do. So this would all distribute, this would distribute. We're not going to mess with the denominator. Let's see here. 3x to the 4th e to the x plus 3x to the 5th e to the x, okay, minus 3e to the x minus 3x e to the x. And over here, minus 12x to the 4th e to the x minus 24x cubed. All over our low squared still. Do we have any common, any like terms, I should say? I don't know if we do. Oh, wait, we have these x to the 4ths e to the x. That's a 5th. That's just e. No, okay, no, there are. So those we can combine. Let's put the 5th power in front. 3x to the 5th e to the x. So that's taken care of. These two would be minus 9x to the 4th e to the x. So those are good. Then we've got minus 3x e to the x minus 3e to the x minus 24x cubed. Let's keep that on the end. And here it is over x to the 4th minus 1 squared. There's our simplified version. You know what? You could factor out like a 3. You cannot factor out an e or x because they not all share, but they, well, I think that's pretty good. Okay, very nice. Love it. Let's stop this video here. We'll continue in a minute.